Alright, so we are busy with exercise number 9.2, and then we looked at the other stuff on the board. We are looking at number 2C now. The question reads as follows: in each of the diagrams, state whether the pairs of triangles are congruent or not, giving reasons for your answers. Alright, so the figure that we have, I'm quickly going to draw the figure. We need to prove that these two triangles are congruent or not. So we would start by saying, and then we're going to start by saying, I'm first going to look at the triangle on the left, and I'm going to say in triangle STK and triangle SKV. SKV, we have the following, namely one, we have hypotenuse. So we have ST is equal to SV, right, is equal to 25, and that our reason there is it is given. And then we have that, now note carefully, we have I actually should have put this one first, but it's fine. But you know now to solve it. So that this will be TKS, all right? TKS is equal to VKS. That's angles on a straight line, and it is equal to what? 90 degrees. Okay, and that is also the one angle is given, but the other one is not given. So we actually need to include there that it is angles on a straight line. So I'm going to say angles on a straight line is equal to 180 degrees. Is equal to 180 degrees, and that's how I got to my second, because my second, the VKS is indicated as 90 degrees, but TKS is not indicated as 90 degrees. So we can't just make assumptions, all right? We need to state that, how did we get to that? Now, and then my third one is that SK is common. SK is common, and then therefore we can say that that means triangle TSK is congruent to which triangle? To now which side is congruent to which angle is congruent? V. All right. So we start with V, and then K, and then S. No, VSK. Sorry. It's VSKS. So it's V, and then S, and then K. V is K, and what is my reason here? RHS, and then RHS stand for right angle, hypotenuse, and side. Okay. So the side that we have there is the you need to have a right angle, okay, in both triangles. Then you need to have the hypotenuse. You can't have, even if you have both of the other two angles, but you don't have the hypotenuse, you cannot prove them to be congruent. The next one, right, at number D we have the following figure. I've illustrated the figure. So what we can say now is we need to prove the two triangles congruent or not. So we can say in triangle DCE. So I would say DCE and triangle ACB. ACB, we have the following. Namely, number one, we can say that, what can we say? Let me just think here before I continue. Right, so we start off and we say our first thing given to us is going to be EC is equal to CA or AC as you prefer. Then we say this is given to us. All right, so our reason is given. Then the next one that we're going to say is that number 2 is ECD, and the emphasis is on C is equal to ACB. ACB, emphasis on C once again, and then we say how it's vertically opposite angles. Vertically opposite angles. Vertically opposite angles, so that means they are the same. And then the other one is we're going to say that number 3, angle D. Now, is it not necessary for me to specify here? Because there's no other lines that it can be, all right? So you can specify like saying EDC, but it's not necessary in this case because you can see there's only one angle. The reason why I specified at C is because it can be any 4 of those angles. So which one am I actually referring to? So be specific, and then B, C is equal to B, and then our reason will be that there's alternating angles. That is because our Z is there, and that is actually our alternating angles. Alternate angles, and then once we make this statement of alternating, corresponding, or co-interior, once we use that, what is important to state? Which lines are parallel. So in this case, our parallel lines is DE is parallel to AB. Okay. They ask us at number 3, find the unknown quantities in each of the pairs of similar diagrams. Now, what we should do, and remember, I think Ms. Jacobs did a very good job of teaching you this. You can actually, and they make it a little difficult for us, but now we can we can give him a name. Let's call this one ABC, so this will be D and E, all right? Now what we have here is actually ABC is not congruent but similar to, so that will be D, E, C, okay? And once we have that, they didn't ask us to prove this, but we can prove this on the following ways. We can say that that and that is an angle, all right? And then somehow this, they don't give it to us, but this is supposed to be parallel to this, and that means I have a Z there, so that angle is equal to that angle right there, and then this angle right here is equal to this angle right here, okay? But they don't ask us to prove us that, but just keep that in mind. If we are to prove it, we should have done it in that way. Now, however, there's something else that you were also taught, and there were a lot of questions that look like this. So what we supposed to say is this equation is AB over, now we check what is the corresponding one, DE is equal to, now we say, so it's AB, it's equal to BC over what is corresponding to BC, it will be DC. DC is equal to, what is left? AC, okay, and then is corresponding to DC, BC. So we have C, EC, EC. Okay, do you remember this now? Now all we have to do here, we need to say what is known to us. So we replace the value, so we say there's AB's value and there's 2 and 3, so that means I'm going to replace that value. So AB is actually 2, and this is BC. Where's BC? BC is Now AC is 3. AC is 3, and then DE is 6. Oh, this is 6. This is 6. And then we need to determine for DE, which is x. Alright? So this value isn't really given to us. Now I'm going to substitute this value. So I'm going to say I'm going to use this one, which is this one and this one. Okay, so I'm going to rewrite it again, and then I'm going to say AB over DE. You don't have to do this step, but I'm just showing you where it comes from. So then it's equal to AC over EC. Okay, that is the sides that I'm going to work with. Now I'm going to replace the values of the sides, and then I have the value of AB. AB is 2 over DE is what I want to determine. DE is x. So I want to determine DE. AC is equal to 3 over 6. Alright, now I do simple algebra, people. I can simple on the left hand side. I can simplify this, or if I don't want to simplify, I can simplify later. But for me, I want to simplify as soon as possible. So that becomes 1 over 2. Okay, now I do cross multiplication. I say this goes with that, so that is x is equal to 4. So that means x is equal to 4.
So you just times it with 2. It's simple. I did it like that.
You did it like that. Yes, I know that is the easy way, but this is how you can explain it. Alright? There's the other way. There's nothing wrong with the other way. For that, if you see, for example, you have the following figure. In the figure, I'm not going to draw the figure now, but you have ratios. Now you can see that RT is actually corresponding to TL. So I took that, the ratio, and that's 3 over 9. And if I simplify that, I have a third. Now if I want to get from the small triangle to the big triangle, I can just do the inverse. So I'm going to not multiply with a third, but I'm going to say multiply with 3. Alright, if I work back, I multiply with a third. So that means I have 2. My one side is ST, and then I say ST is 2 times with 3, which is my and then I get my answer 6, and then I have in my big triangle I have 12. Now I'm going back, so I'm going to say 12, but I'm not going to multiply by 3. I'm going to multiply by its inverse. So I can either divide by 3, or I can multiply with its reciprocal, which is 1 over 3, and then I get my answer, which is 4. Okay, are we clear on that? So you don't have, if it's only 1 point, I would suggest do it on your calculator if you can see the ratio. Okay, you don't have to do everything, this writing process for 2 marks. All right, it's not time efficient. So don't waste time on unnecessary stuff. We can do the next one of D on the similar way. So D, we have BD is equal to 1, and what is the ratio there? I don't know why I use this, because this is actually the same ratio the whole time. What is the ratio there? It's 5 and 15. What is 5 divided by 15? 1 over 3. Alright, so the ratio is once again 1 over 3. So if I want to get to 2, so my one answer will be for x will also be 2 times with 3, so it becomes 6. And then my other side will be 1 times with, oh, but this is the catch. The catch is now we are supposed to subtract, because x is not the whole side, but only stretching from EC. So x is actually the length of EC. It's not the length of BC. So we need to say there